Hi everyone, in this video we'll be looking at question number 19 from 2020 HSC Standard Maths exam. This question came from the topic of nonlinear relationships and from parabola. And this question is one of the harder questions, so make sure you understand the concepts very well. So look at question number 19. What you're told is that a fence is to be built in this way on a field, and you're told that a total of 900 meters of fencing is used. So basically this y and this y, so 2 times y and x, 3x. So 3x plus 2y is equal to 900. And what you're also told is the area of this block of land is given by this equation. So 450x minus 1.5x square. That's the area, and you're given the chart of the area for different values of x. So if you select a shorter value, then the area would be smaller, whereas if you keep going up, the area increases, and beyond the point the area decreases. So this is the area going down, and this is the area maximized at a certain point. And then a few questions are asked, so let's take them out. What your first question that you're being asked is, if the area of the paddock is 30,000 meters square, if they're saying that, okay, we are giving you that this is the area that we want to work with, 30,000, what is the largest possible value of x? So what you need to do is look at the chart, area of 30,000. So this is here, 30,000, and you need to draw a line or just put a scale and try to work out what are the x values for the corresponding area value. So one value is 200, the other value is 100. But the question specifically asks for the largest possible value of x. So the largest possible value of x is 200. So it's here. So that would be the answer. Now moving on to the second part, find the values of x and y so that the area is as large as possible. Now they are asking that we don't know what the area is, but what we want you to do is to maximize this area. So the maximum area is somewhere here. If you look at the graph, it's just somewhere around here is the maximum area. We don't know exactly where it is, so that's where you need to do a bit of trial and error. Try playing with different values of x. So try playing with 148, 149, 150, and so on. I did that before this video, so I know the maximized area is maximized at when x is equal to 150, and the way I did that calculation would be area is equal to 450 times 150 minus 1.5 times 150 square. So this is this equation. You're just plugging in the different values of x. So here I'm plugging in the value of 150. So the area that you're going to get, the maximum area would be 33,750, right? Now the question is asking what are the values of x and y. We know the value of x for this maximum area is 33,750. The value of y for that is, you use this equation. So actually 3 times 150 plus 2 times y is equal to 900. So if you solve this equation, you will get y is equal to 225. So that would be your answer for part B. Now what you're being asked is, what is the value, using the values from part B, the largest possible area. We already worked this out over here when we were actually calculating the value of x. So the largest possible area is 33,750, which is somewhere here, this point. So those are your answers.